Hi, my name is Bridget Hart, and I'm a junior at Yorktown High School. For my science fair project, I tested the effect of different purification methods utilized in the developing world on the purification of inorganic contaminants in water. Some of the background to doing this project was that I learned that 1 in 10 people still lacked access to clean water, and the global definition of clean water isn't that transparent. A lot of water that's considered clean still has a lot of contaminants in it. And I found that most purification methods that are used in the developing world focus on microbial contaminants, which are extremely important to filter out because they cause a lot of diarrheal diseases that claim a lot of children's lives under the age of 5. But there's also inorganic contaminants like lead and nitrate and fluorine that can also cause a lot of problems, but a lot of the filters or other methods are too have too large of pores to filter those out, so I wanted to see their effectiveness with these inorganic contaminants. I chose nitrate because it was relatively easy to test, and there's a couple health issues that are linked to nitrate to some degree. My research project for this experiment became which household water treatment method used in the developing world will be most effective at removing inorganic contaminants from the water, and the inorganic contaminant I was testing was nitrate. The hypothesis was if the LifeStraw personal filter straw is used, then it will be most effective at removing the nitrate. However, no filter will remove all the nitrate. This was hypothesized because the LifeStraw is pretty well developed and has a lot of technology in the small filter, and it's not as simple as like a ceramic or sand filter, so I thought this would work better. And I didn't think any filter would remove all the nitrate because the pore sizes are a lot larger than nitrate generally is. The independent variable was the type of purification method used, and 3 of these methods were filters, and they include the LifeStraw personal water filter, the sand filter, and the ceramic filter. One of these was not a filter method, but a purification method focused on utilizing the sun's rays as UV rays to kill all the bacteria, and that's called solar disinfection, and it's abbreviated SODIS. The dependent variable was the amount of nitrate removed, and some constants included the test strips that I used, the original solution and how much nitrate was in it, the person who observed the color change because different people have different color vision, and I did 10 trials at each level for repeatability. So my basic procedures were first to prepare the nitrate solution and then set up the filter or purification method based on its needs. Some needed a vacuum filtration to pull it through and some didn't. Then I would test the water before I purified it, perform the purification method, and test the water again. I'd compare the original reading of nitrate to the final reading of nitrate, and then I repeated this for 10 trials of each of the 4 purification methods. I'll show you some pictures of the purification methods on the next slide. So starting on the left side of the screen shows the LifeStraw personal water filter, and for this one I had to use a vacuum filtration because it's usually the filter works by someone sucking the water through the straw. So I attached the vacuum filtration and collected the purified water into the flask. Over to the center picture, that's the sand filter, and that just uses gravity to pull the water through. So you can see the gravel layer and then the sand layer, and the purified water comes into the beaker. Over on the top right-hand picture is the ceramic filter, and in the beaker there's this nitrate solution, and then the ceramic filter's inside that, and the water gets pulled into the filter and then up through the straw with the vacuum filtration, because once again it was not strong enough with just gravity based on this cartridge. Then down in the bottom right hand corner is a picture of the setting up for the solar disinfection, and I just put a little bit of water in each of the plastic bottles and then placed them in the sun for 2 days, and that was supposed to purify the water. Here's my data table showing the change in nitrate content from the beginning of the experiment to the end. Here are 2 graphs showing the same data. On the left is the raw data with all the trials, and on the right is the average data. So as you can see, the LifeStraw sand and ceramic filter all had about the same amount of change in nitrate, and the solar disinfection had no effect on the nitrate. This slide shows a box and whisker plot of the data that shows the spread in the data. So the LifeStraw and sand filter had quite a spread and a couple outliers, whereas the ceramic and the sodas didn't have any variation in their data. On the right is a summary of the statistics. So I did a one-way ANOVA test, and I went into it with a confidence level of 95%. There's only a statistically significant difference between the solar disinfection and each of the filters, but not among the filters, which makes a lot of sense because they all had the same mean value. The statistically significant difference is because the p-value was less than 0.05, which would fulfill the confidence level. To summarize the results, all three filters had similar effectiveness, and the solar disinfection had no effect on the nitrate content. There was a bigger range for the sand and LifeStraw filters, and the data was limited to the precision of the nitrate test strips because they only measured certain levels of nitrate content. They couldn't do in between. The hypothesis was partially confirmed because while the LifeStraw was not more effective than any of the other filters at removing nitrate, none of the filters removed all the nitrate, which was hypothesized. And this makes sense because the filters all have similar sized pores, so the molecules either fit through or don't. And since the solar disinfection does not remove any molecules, it makes a lot of sense that the nitrate content wouldn't change at all. Putting this project into a context, in the world, microbial threats definitely take priority in water concerns, but chemical pollutants can have long-term effects too. Nitrate content in water has been linked with infantile methemoglobinemia, which it may not completely cause it, but is a factor in this. And this affects pregnant women and their children, and it's also called baby blue syndrome when it turns the hemoglobin molecules into methemoglobin and it can't carry the oxygen. This is also seen present day in Flint, Michigan, where there's a lot of problems because of the lead in the water. So moving forward, while microbial threats are really important, we need to look at what inorganic molecules are getting into our water and how they might affect us in a more long-term way. Also, moving forward, since all three filters had similar effectiveness, sustainability is a key thing to consider because depending on the region, the cost could change a lot. For the different filters, like some places might have more materials for ceramic filters and some maybe for sand, and also the culture and what their values are and how much they'll put into the water filtration. Some of the experimental error was with the nitrate test strips because they weren't super precise, and I had trouble figuring out at which point to record the color because it changed in the span of like 2 or 3 minutes. There also could have been error in the vacuum filtration because the speed at which the water molecules were moving through the filter might have been much different than they're moving in reality, and that could change how much is filtered out. Some future studies that I could continue this experiment could include testing the same filters with organic contaminants, like the microbial threats, to see how effective they are. I could also try other household water treatment methods, maybe with chemical treatment or other kinds of filters. Or I might do a research-based project about the cost efficiency of the different methods, depending on the world region and the resources they have. I also, if I was going to test the exact same hypothesis, I would measure the nitrate content and other inorganic contaminants in a different way, maybe not with test strips, to see if I could get a more precise reading. Here are the 2 slides with the references I used for this project to do background research and draw conclusions. Thank you for your time.